The James Webb Space Telescope just showed us something incredible. Light beams that look like they're coming from a city super far away. This has everyone wondering again about aliens. The telescope zoomed in on Proxima Centauri b, which is the closest planet outside our solar system, and it saw some weird, bright flashes. Could these be signs of aliens? We'll have to wait and see what happens next. People have always been fascinated by the thought of life beyond Earth. Any little clue that suggests there might be life out there gets people excited. But when the James Webb Space Telescope showed what seemed to be real proof, everything changed. While checking out deep space, this powerful telescope spotted something amazing on a distant planet. Lights that looked like they were from alien cities. This made people think that there may be an alien city on that far-off planet. The science world is pretty hyped about this since it could be the thing they have been waiting for. It makes you consider that there might be smart beings running cities in strange ways. NASA folks are scratching their heads at these city-like lights from 4 light years away, wondering how long they've been there and if we've only just got the tech to see them. David Kipping, an astronomer at Columbia University, said that this planet where the lights were spotted is really weird. Unlike most rocky planets that soak up sunlight and spit out heat, this one acts differently because of how it hangs out with its star, Proxima Centauri. This spot by the James Webb Space Telescope proves just how important the telescope is. It can spot infrared light, which helped it see Proxima Centauri b's unusual behavior. This is key to understanding what its atmosphere is like. Researchers plan to keep using the telescope to check out the planet's atmosphere in more detail, hoping to find out if anything could live there. The James Webb Space Telescope is good at seeing infrared light, so it can watch what happens on Proxima Centauri b even when it's dark. Loads of telescopes couldn't pick up dim lights in the dark space. But the Webb telescope is great at seeing even the faintest glimmers. This makes it the perfect tool to check if those city lights on the dark side of Proxima b are real. The telescope can spot artificial light in space if it's in a very specific frequency range that's much smaller than the light from regular stars. Proxima Centauri b and its star have a strong bond, which really messes with the planet, kind of like how planets orbit stars. It gets tons of power from Proxima Centauri. As it circles its star, it goes through days and nights. Just like Earth, it gets super hot during the day and colder at night. The temperature range on Proxima Centauri b is huge, mostly because of what it's made of. If it has an atmosphere, the temperature change between day and night would be wild, scorching on one side and freezing on the other. This crazy temperature thing is something that astronomers are checking out because it gives them info about Proxima Centauri b's atmosphere. The James Webb Space Telescope can take pictures in the infrared spectrum, so it can check out the planet's heat and tell us about its atmosphere. The James Webb Space Telescope circles Earth at the same speed that Proxima Centauri b orbits, so scientists can do fancy observations of its daily routine every 11.2 Earth days. If Proxima Centauri b has air, the next thing to do will be testing its chemistry to know whether it can hold life. Spotting stuff like oxygen, water vapor, and methane would mean it could be a place with real life. This would mean checking the light filtering through the planet's air, which is not easy. Even though the James Webb Space Telescope is good at looking at planet air, it isn't made for that job. It's better at seeing the amounts of water vapor, carbon dioxide, and methane. It's not that good at seeing pure oxygen, but that's an important clue for life. But the telescope can search for signs like ozone that means a happening atmosphere. As scientists look at the numbers from the James Webb Space Telescope, the hunt for what's out there never stops. We're getting closer to figuring out if we're just the only ones in the universe. Keep in mind that James Webb Space Telescope can see only some of the closest planets to Earth for more look into planet air. Astronomers will need to use ground observatories like the extremely large telescope ELT. ELT will be better to check out remote air config and furnishing clear data to know their ability to uphold existence. Scientists are pumped for more space telescopes to come out and use. For now, the James Webb Space Telescope matters a bunch for Explore Distant X Webb Telescope continue to offer data that may alter our comprehension of what in our solar system. Researchers are having ideas about how telescopes will look. They want to make technologies that dim starlight interference, enabling superior observation of the planets. They will be able to think about the radiance from X and assessing whether they might be capable of sustaining life. Stars are also crazy bright, so it's tough to see dim light from planets. One way to tackle this is with coronagraphs. These things are in telescopes to block starlight while letting planet light pass. By crafting the light waves, coronagraphs can tone down the glow from stars, so it's a cinch to spot the dim light from XOP's dot. Another trick is the star shape. It's a flower-style spacecraft that will walk with a telescope thousands of kilometers away. The star shade blocks starlight before it hits the telescope, letting only the light from exoplanets get to the instruments. This thing could be great at seeing planets in the habitable area where water and life might live. The thing need to line up to parts of a millimeter across large areas. These things must make the demand for miniaturization, energy economy, and must able to withstand in space. Say we can check the atmospheres of exoplanets and see chemicals in those atmospheres like oxygen, methane, or water in the right amounts. Those molecules could mean activity implying life out there. Researchers are also looking at ways to get clearer pictures and scrutinization of these far, distant stars. Some telescopes will get better adaptive lenses, fix air disruption, and sharp picks. These make it so scientists can not only find exoplanets but also map their surfaces and scrutinize weather and climates. New space telescopes are big new step in for find out if we only in space. Finding to look distant is how to be know that. Space and finding stuff out in space is going fast. Astronomers and the James Webb Space Telescope is opening up a new exploration is. How do you think that the James Webb Telescope find out in the future? Researchers will keep using the telescope to check out the planet's atmosphere to see if it could support life. The James Webb Space Telescope is great at seeing infrared light, so it can see what's happening on Proxima Centauri b, even at night. Other telescopes have trouble seeing faint light in space, but this one can pick up even the tiniest glimmers. That makes it perfect for checking if those city lights are real. The telescope can spot artificial light in space if it's in a very specific range, much smaller than the light from stars. Proxima Centauri b gets a lot of energy from its star, like many planets. It goes through day and night cycles as it orbits. Like Earth, it gets hot during the day and cools off at night. The temperatures on Proxima Centauri b change a lot, mostly because of what it's made of. If it has an atmosphere, the temperature difference between day and night would be huge, boiling hot on one side and freezing on the other. This is something astronomers are looking at to learn more about the planet's atmosphere. The James Webb Space Telescope can study the planet's heat to figure out what its atmosphere is like. Interestingly, the James Webb Space Telescope orbits Earth at the same rate that Proxima Centauri b orbits its star. This lets scientists watch the planet's daily cycles every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step is to check what it's made of to see if it could support life. Finding things like oxygen, water, and methane would suggest that the planet could have life. This means studying the light that passes through the planet's atmosphere, which is tricky. The James Webb Space Telescope is good at looking at planetary atmospheres, but it was made for other things too. It's good at seeing water, carbon dioxide, and methane, but not as good at seeing plain oxygen, which is a sign of life. Still, it can look for other signals like ozone, which means a good atmosphere. Scientists are looking at the data from the James Webb Space Telescope, and the search for planets is still on. We're getting closer to finding out if we're alone in the universe. The James Webb Space Telescope can only see a few exoplanets close to Earth for detailed atmosphere studies. Astronomers will use ground-based telescopes like the Extremely Large Telescope (ELT), which should be up and running in 2027. The ELT is designed to take a closer look at the atmospheres of exoplanets and give us more info on whether they can support life. Scientists are excited about new space telescopes like the ELT. For now, the James Webb Space Telescope is still valuable for exploring exoplanets. Even with its limits, it keeps giving us important info that could change how we see what's out there. Researchers have big plans for future space telescopes. They want to create technology that blocks starlight so we can see the planets around them better, like using your hand to block the sun. These telescopes will be able to focus on the faint light from exoplanets, helping us study their atmospheres and see if they could have life. But it's not easy. Stars are super bright, often much brighter than the planets next to them. This makes it hard to see the faint light that planets reflect, which we need to study them. To fix this, scientists are working on new methods. One is using coronagraphs, which are inside telescopes to block starlight but let the light from the planet through. By carefully shaping the light, coronagraphs can reduce the star's brightness, making it easier to see the planet. Another idea is the star shade, a huge flower-shaped spacecraft that will travel with a telescope far away. The star shade blocks starlight before it even gets to the telescope, letting only the light from exoplanets reach the instruments. This could be helpful for seeing planets in the habitable zone of their stars, where water and life might be able to exist. These technologies need to be super precise. For example, the alignment of a star shade has to be perfect to tiny fractions of a millimeter across huge distances. Plus, these need to work with the challenges of space missions like being small, using little energy, and surviving the conditions of space. Even with these problems, the rewards could be huge. If we can see and study the atmospheres of exoplanets, we might find biosignatures, chemical signs of life, like oxygen, methane, or water in certain amounts. These chemicals could mean that life exists beyond Earth. Researchers are also finding ways to get direct images of planets in more detail. Future telescopes could have adaptive optics, which fix distortions caused by Earth's atmosphere or the telescope's movements, giving us clearer pictures along with starlight blocking tech. These would let scientists not only see exoplanets but also map their surfaces and study their climates. New space telescopes are a big step in our quest to answer a big question. Are we alone in the universe? By improving our ability to see these distant planets, we're getting closer to finding out if there's life beyond Earth. Space exploration and the search for life are moving fast. As scientists study exoplanets, the James Webb Space Telescope is starting a new time of space exploration. The information it gets helps astronomers make new about the makeup and possible living on other planets. With each new finding, we get closer to that big question. Is there life out there? Finding Proxima Centauri b is just the start of something huge in how we look for alien life. Proxima Centauri b is the closest star to us, so it's been a focus for years. But until now, finding real of life like lights was just a dream. The fact that the Webb telescope saw these lights makes us hope that one day we might talk to other smart life forms in the universe. This kind of discovery gets both scientists and the public excited and inspires new people to think beyond Earth. As the James Webb Space Telescope keeps watching, it's not just looking for lights but also studying planetary atmospheres, their chemistry, and if these things could support life. Looking for certain biosignatures like methane or carbon dioxide is key to knowing if planets have the right conditions for life. The Webb telescope can study these things better than any other telescope, showing what distant worlds might be able to support life like Earth. One of the coolest things about Proxima Centauri b is that it's in the habitable zone of its star, where it might be warm enough for liquid water to exist on its surface. The habitable zone is where temperatures are just right, not too hot and not too cold. This is seen as important for whether a planet could support life. Water is needed for life as we know it, so finding a planet in a habitable zone is a big goal for future searches. Besides identifying life's planets, future space telescopes will also emphasize the between exoplanets and their stars. Some planets like Proxima Centauri b are tidally locked. One side invariably confronts the star while the other side persists in obscurity, and that engender drastic temperature disparities, affecting the planet's climate and its aptitude to sustain vitality. Knowing these things is important for astronomers when they think about the chances of planets being habitable. Making technology that can block the bright light from stars is another big step in space exploration. Without blocking starlight, it would be hard to see the faint light from distant planets.